Okay, so basically we were discussing complex numbers. So let's talk about the next section. Okay, so basically we will talk about complex roots of polynomial equations. Okay, now basically so far you have been dealing with real solutions, and there used to be times when you used to get x equals under root negative something and you used to write no real solution. This time they want you to find out that no real solution. That no real solution is basically your complex solution. Okay, that is the only difference. That is it. Okay, so let's talk about the first example for today. Okay, we are talking about complex roots of polynomial equations. It is example number 1. So the question says find all the roots of the equation z cube plus 4z square plus z equals 26, given that one root is 2, full stop. Okay, forget about the fact that we are studying complex numbers. Okay, forget about that. Just know that you have a cubic equation and you need to find the roots. So how do we find roots of any cubic equation? Let's talk about the solution. So we know that even if it's a quadratic equation, even if it's a cubic equation, we want to find the factors. Okay, once we have our factors, we can easily find the roots. So basically we can write it as z cube plus 4z square plus z minus 26 equals 0. We are interested in the factors of this whole expression, just so we can write them this way, equate it to 0, and then we can say this is 0, this is 0, this is 0. All these would be linear and we would be able to find the values of z. So this is our plan. Okay. In order to find the factors, we need to factorize. Okay. So they are saying one root is 2. If 2 is a root, 2 is a root means z
Minus 2 is a factor.
very good. Z minus 2 would be a factor. Excellent. Okay. So we need to find the other factor. How do we find the other factor? By doing division. Okay.
Division, long
Very,
division.
very good. So this is z cube plus 4z square plus z minus 26, z minus 2. So we need z cube here. So what do we write here?
You write Z square.
Very well done. Excellent. Okay. So we will have z square here and this will give us z cube
Z
minus
cube
2.
minus 2Z
Mhm.
square.
Very good. Excellent. Okay. So this is negative. So these two would be cancelled and you have 4z square minus into minus.
6Z square.
Very good. 6z square plus z minus 26. Now, what number should we multiply? Like what number should I multiply? Yes, what number should I multiply with z minus 2 to get 6z square? 6z?
6Z.
Very good. So this would be 6z square.
6Z square minus 12Z.
Okay, and we have to subtract this. These two would be
That will
cancelled
be
and
13Z minus
mhm,
26.
excellent. And finally, we need to multiply it with 13. Okay,
13.
very good. And that will give you 13z minus 26 and the difference
Like
would be
0.
0. Perfect. So the other factor has turned out to be this one. So I can rub the long division because you were good at it and we know the factor. So we have our factors. The first factor is z minus 2. This equals 0. And how do we factorize this? Okay, let's
You can
think.
take z minus 2 as 0 and z square plus 6z square.
Yes. Okay. All right. So let's think about it this way, that we have our two big factors. Once we have our two factors, this means that either z minus 2 would be 0, or z square plus 6z plus 13 would be 0. So this would give you z equals 2. And what about this? So z equals 2 is what root? Is it a complex root or a real root?
Real root.
Very good. Okay. So this is a real root, and we are interested in finding out the solution for z. Okay. Now you can do it through different ways. Okay. So let's just do it the way we are comfortable doing it. That is, you are solving a simple quadratic equation. Forget about the fact that we're talking about complex numbers. Okay. So it is, you cannot find it by middle term breaking, like 13 is a prime number. 1 into 13 would not give you 6x. So just try doing it using the quadratic formula. A is 1, B is 6, and Z is and C is 13, right?
Yes.
C is 13. So Z would be minus P plus minus under root B square is 36 minus 4. A is 1 and C is 13 divided by 2. So Z is minus 6 plus minus 36 minus 4 into 13 will give you what? 4 into 13 is 52. So this would be minus 16 divided by 2, right? Okay. Now, if you were, let's say, an O-level student, you would have just, said that no real solution, you would have ended it, okay? But look at the statement. Find all the roots. They did not tell you to find out the real solutions only, okay? They have to ask you to find out all the roots. In this case, you have to find both the complex and the real solutions. Okay, so what would be the complex roots? You can write it as z equals minus 6 plus minus 4 iota divided by 2, right? Did you understand why I got 4 iota from
4
there?
iota.
Why 4 iota?
No.
Because, okay.
Yeah.
Okay, because we have minus 16. Minus 16 can be written as under root minus 1 multiplied by under root 16. I told you that this is the very beginning of the complex numbers. Under root
Yeah.
minus 1 is iota and under root 16 is 4. Okay. This is
4.
why we are
Okay.
able to now find the solution of, we are able to find no real solutions now, because this is our, helper. We can write it as iota. So this would be minus 6 plus minus 4 iota divided by 2, and you can write it separately. That would be z equals 6 by 2 minus 3 plus 2 iota. I have divided 2 by 6 and 4, and the other one would be minus 3 minus 2 iota, right? So these are the three solutions. As I told you before as well, whenever you are getting this complex root, you will also get its conjugate. Okay, that this is a rule. Roots come in pair, like complex roots come in pairs. Okay, you will always have the conjugate of the complex root which you are getting, right? This is the rule. Always remember this. Okay.
Yes.
So did you understand this example completely?
Yes.
Okay, perfect. Let's talk about, this was a simple example. You were solving a cubic equation. The only trick was in this part. That is it. That's it. Okay. Let's talk about the next example. So that is example number 2. So the question says the quadratic equation x square plus ax plus p equals 0 has a root 3 plus 9 iota. Find the values of A and B. Okay. Now, basically, in this question, you have been told that this is a quadratic equation. That is obvious because the power is 2. A and B are the coefficients of x and B is the constant term. And they told you that this has this root. Find the values of A and B. Okay. So for this question, first of all, you need to understand one thing. If x equals 3 plus 9 iota is a root, what would be the other root? Yes, 3.
The other root will be
3 minus 9
3
iota.
minus
Okay.
9.
Because I told you already, whenever we have one complex number, its conjugate would also be the root. Okay. So if this is the root, this would also be the root. This is a rule, okay, which holds in general. So we know that these two would be the roots. Now, can I write down this equation as a product of its factors? Can I write down this equation as a product of its factors?
Yes, you can.
Okay. All right. So you can write it as x minus 3 plus 9 iota and then x minus 3 minus 9 iota equals 0. Okay. Now we need to, let's just simplify this first, or maybe we can directly multiply it. So x into x will give you
Well,
x square minus x into 3 minus 9 iota. Then I will multiply this term with x. This
how
will
did
be,
you get x square minus x square?
say it again.
How did you get minus? How did you get
Okay,
minus x?
because this is minus sign here. Because of this minus, okay? X into minus 3 minus 9 iota, right? Wait, I'll do it again.
Oh, okay, yeah, I got it.
Okay.
I got it. That's fine.
Okay, so this is 9 iota. Okay, so basically we have multiplied this x with this term. Now let me use a different color. Now we have this factor. I will multiply it with x. So I am going to get minus x 3 plus 9 iota. Okay, be very careful with these signs. And I will rub the extra lines because that is making it even more confusing. And I'm left with the last multiplication. So what would that be? I need to multiply this with the last factor. So minus and minus would be plus 3 plus 9 iota and 3 minus 9 iota equals 0, right? After this, I will share a direct method as well. Like you can do it other way around as well. But yes, for now, just follow this. So it would be x square minus 3x plus 9x iota minus 3x minus 9x iota. This and this would be cancelled. Then we have, okay, plus sign, and then this is a plus p and a minus p, right? Can we do it that way?
Yes.
So this is 3 square minus 9 iota square equals 0. So x square minus 3x minus 3x, 6x plus 9 minus 81 iota square is minus 1, right?
Yes.
So I already had a minus sign this one. So minus into minus would be plus 81. Did you understand this?
Yes.
Okay, perfect. So this equals 0. And finally, we are going to have x square minus 6x plus 90 equals 0. Okay, so this is the equation, and this means that what would be the value of a? The value of a is basically the coefficient of x, so a would be minus x because we have plus here. Okay, this means that a has that negative sign. Did you understand this?
Can you please repeat it again?
Sure. Okay. So what was the question exactly? Why were we doing this? Why did we just, multiply the factors and all that? Because we are interested in finding out the values of A and B. Okay. So we just got our root.
I can't hear you.
Can you hear me now? Can you hear me now?
Yes, I can hear you now.
Okay. So basically, what was the question? The question was to find the values of A and B, given that it's a quadratic equation and this was a root. Okay. So from the roots, we got our factors, we multiplied those factors, and finally we got this equation. We have to compare this equation in the box with the equation in the question to find out the values of A and B. A is the coefficient of x. So what would be the value of A?
A is the coefficient of x, so A will be 1.
X, okay, X, not x square. X. This is x.
So 6, negative 6.
Very good, okay. And what about B?
B will be 9.
90.
90.
Perfect, okay.
Yeah, 90.
So the concept in this question was not to find out the values of A and B, but the fact if this is a root, this would also be a root, okay. Now I'll share another method of doing this question. Did you understand this method?
Yes, I did.
Okay, this is much more better because this method makes more sense, the one which we have done. But I would like to share the method in your they have used in your book as well. So we have okay. Now when we got these two roots, so we can write it as a combined root that x would be 3 plus minus 9 iota, right? And now I can just try making this x minus 3. I have taken 3 to the other side, and this is plus minus 9 iota. Now I have squared both sides just to get rid of this iota. Okay. And when I will square this, even if it is negative 9 iota, it would become positive. And if it is positive, it would be positive, right? So x minus 3, 9 square is 81. And then iota square would be minus 1, right? So this would give you x minus 3 whole square equals minus 81. Did you understand this? Okay, look. This is what we are getting from the question. This was one root. This would be the other root. I have just written them together. Now, I want to get rid of this iota. I know how can we get rid of this iota by basically making iota square, right? Because that will give me minus 1. So I have squared both sides, okay? I've squared the left side and the right side. For the left side, I got simple square. For the right side, don't get confused with these plus minus signs, okay? You need to understand the concept. When you are squaring something that is negative, the value would become positive. When you are
Positive.
squaring something that is positive, the value would still be positive. So forget
Positive.
about this plus minus. Just square 9, that is 81, and square iota. So iota square is minus 1. This is why I got minus 1, right? And this would be the equation. And finally, this is not in the question form. In order to find the values of A and B, my equation should be in this form. So I will expand this x minus 3 whole square. It would be x square minus 6x plus 9, right? And then I have minus 81 on the other side. I'll take it to this side and this will give me x square minus 6x plus 9 plus 81 equals 0. And again, I am getting the same thing.
Yes, you will.
Okay, so did you understand this question?
Yes. I
Okay.
think this is a much better method. Like
Okay.
it's faster.
Yeah, okay. All right. So this was the section of the complex roots. Let's talk about the next section. Let's talk about 9.4. That is polar form. Okay. So basically, so far we have discussed z equals x plus iota 1, where this is the real part and this is the imaginary part of z, right? This is the form which we have discussed. Here they want us to talk about the polar form. So I will write down the polar form in a different color. Z is equal to, and this is the polar form, R cos theta plus iota sine theta, right? So this
Yes.
is the polar form of the complex numbers. Now the questions could be of this type. Convert, like they would give you the complex number in this form and they would want you to convert this to the polar form, right? So in order to do that, we have two formulas. We have a formula for r, we have a formula for theta. R is basically under the root x square plus y square. X is basically the real part of z, y is basically the imaginary part of z. And for theta, we do tan inverse y divided by x. That's it. This will give you r, this will give you theta. Once you have r and theta, just use this form, plug in the values of r, plug in the values of theta, and you will get your answer in polar form, right?
Okay.
Did you understand this? Okay, you will get a better understanding once we do some questions. So let's do some.
Will always be cos theta plus I sine theta, right?
Yes, yes, yes. This is the polar form. Okay. Then we have another form as well that we call exponential form. It's not that popular, but still it's in your book. So I'll write that down as well. But for now, just know this is the polar form and this is the general form, right? So basically, if I make three boxes or maybe two, because we have been talking about the simple form and we're talking about the polar and exponential now. So Z is R cos theta plus iota sine theta. You will always have plus, you will always have cos, you will always have sine, and you will always have R. Okay. This is something that holds in general. And the exponential form is basically Z equals R e to the iota theta. That's it. Because you can write this as e to the iota theta. There's a proper proof for that, which is not included in the syllabus. But yes, since you can write cos theta plus iota sine theta as e to the iota theta, so this basically means that you can write it as z equals r into e to the iota theta. So this is your polar form and this is the exponential form, right? There are two simple forms. You need to use r, you need to use theta to find these forms. That's it, okay? And you will be able to find r and theta easily once you have your x and y's. Okay, so just understand this and you will get a better understanding once we do the examples. So let's talk about the first example of this section. It is example number 1. So the question says, write down the polar and exponential forms of the following complex numbers. Okay, so a part is z equals 8 plus 8 under root 3 iota. So let's find the polar form first. Before talking about the solution, I will just write down the formula which we use for the polar form. So it is z equals r, bracket open, cos theta plus iota sine theta. And we know that r is calculated by under root x square plus y square. What is my x? This is x, and what is y? This is y, right? This whole thing. So r would be under the root x square, that is 8 square, plus y square, that is 8 under root 3 square, and this will turn out to be under root 64 plus 64 into 3, and this will give you 16. You can calculate that on your own as well and just check if you're getting the same answer. Yes, and your answer would be 16. Okay, so this is your r, and we have the r. We are interested in finding out the theta now. So we got r, we want to find theta. Theta again has a formula, that is tan inverse y divided by x So it is going to be
8 root 3 by 8.
say it again.
8 root 3 I by 8.
8 root 3i.
Yeah, because of
No, what is your theta? Like theta doesn't have any I, it's y by x. So this would be tan inverse. What is y? Y is 8 under root 3. Okay, it does not have iota. Divided by 8, 8 and 8 would be cancelled, and tan inverse under root 3.
60.
Yes, it is 60. And what is the value in radians?
Pi by 3.
Yes, it's pi by 3. Okay, it's pi by 3. So we can write it as pi by 3. Now, obviously, it totally depends on the question if they are interested in finding out the theta in radians or in degrees. But most of the times, you will see that they would be using radians. Okay, so it's good that we use radians for this. Okay, because at times we will talk about some questions where they give you the range in radians. So in that case, obviously, we will be talking about the theta in radians. So this would be z equals r, that is 16, cos theta, that is pi by 3 plus iota, that is iota, sine pi by 3, right? This would be the polar form of this complex number. Did you understand this?
Yes.
Okay, and if I want to find the exponential form, it's very, very easy. Z equals r e to the iota theta. Now, how do I find r and theta? There's no point in finding it out because we already have r and theta. So it would be 16 e to the iota pi by 3, right? So this would be your answer. So did you understand this example completely?
Yes.
Okay. So let's talk about the next part of same example, just so we get to practice more. Okay. So I want you to do this one. It is the second part, and obviously if you're not able to do it, I'll do it. Z equals 8 minus 2 iota. So find the polar and complex forms, okay?
Yes.
Yes, Ranjani, are you able to do it?
Yes.
Okay.
1 second.
Mm-hmm.
8 minus 2i is 2 root 17.
Very good. And yeah, I'm not able to hear you properly. R is 2 root 17.
Yes, 2 root 17. And then I have to do tan inverse of
Mm-hmm.
tan
Of
inverse of 2 by 8.
minus 2 by 8, okay?
Yeah, tan inverse of minus 2 by 8. Negative 0.245.
Very good, okay? Yes. And then you will get the answer as this. So R is 2 under root 17
2 under root 17
cos.
times cos negative 245.
Very good. Okay. This is the polar form, and the exponential form would be again R, that is 2 under root 17, and then we have e to the power iota theta. So that would be minus 0.245 iota, right?
Yes.
Okay. So these were some examples. Okay. Now we have discussed how to multiply complex numbers, how to divide them, how to add and subtract them, right? But we need to talk about the same thing in polar form, okay? Because this is what we are talking about. So let's talk about the multiplication of complex numbers. In polar form. Okay. So let's say that you have Z1 that has a different R, like it has R1 cos theta 1 plus iota sine theta 1, right? This is your Z1. And Z2 has R2, then cos theta 2 plus iota sine theta 2. So we have two complex numbers that are written in the polar form, and we are interested in their multiplication. So let's do it. In order to multiply this, we will get Z1, Z2, we are multiplying them. So we will have Z1, that is R1 cos theta 1 plus iota sine theta 1 multiplied by Z2, that is R2 cos theta 2 plus iota sine theta 2, right? This should be the solution. Okay, now let's do it. So we can write R1 and R2 together, R1 and R2, and we can write these brackets together just so things make more sense. Cos theta 2 plus iota sine theta 2. Okay, now simply I need to just open up the brackets. So cos theta 1 multiplied by cos theta 2. This will give me R1, R2 is fixed, and this would be cos theta 1, cos theta 2. Then again cos theta 1 multiplied by iota sine theta 2. So this should be plus iota sine theta 2 and then cos theta 1. Then we have plus, I have to multiply this with the first factor. So I'll multiply the old arrow. This time I'm multiplying this factor with this one. It should be iota sine theta 1 cos theta 2. And then finally the second factor with the second factor. Okay. So this would be plus iota square because we have two iotas, sine theta 1 and sine theta 2. Okay, let's just simplify all this. So we are going to get R1, R2, cos theta 1, cos theta 2. Okay, let's write down the terms without iota on one side and with iota on the other side. So these are the terms with iota. I'll write them here. Here maybe. So it is iota sine theta 2 cos theta 1 plus iota sine theta 1 cos theta 2. Bracket closed. And this term would basically become what? Iota square is -1. Okay, so it would become minus sine theta 1 sine theta 2. Finally, I am going to get this R1, R2. What is this, Ranjani? Isn't this cos theta 1 plus theta 2?
Yes.
Okay, so I can write cos theta 1 plus theta 2, and then I can take iota out plus iota out. So if I write this as this without the iota, what is this?
Sine
Sine
theta.
hmm,
Yes. Sine
theta 1 plus theta 2, right?
theta 2.
Yes,
Yes.
this means that when we are multiplying two complex numbers, we need to multiply their r's, right? The radius which we get, like r1 and r2, and we need to add the thetas, right? So this would be the final complex number which we get after the multiplication of two complex numbers, right? So did you understand this completely?
Yes.
All right. So before talking about its division and all that, let's just do an example just so things make more sense. Let's say I have, for an example, I have z1 as 10 cos 2 pi by 7 plus iota sine 2 pi by 7. This is the first complex number. The second one is 2 cos 9 pi by 14 plus iota sine 9 pi by 14, and you have been asked to multiply these. So z1 into z2 is what? r1 r2, a big bracket. The same thing, cos theta 1 plus theta 2 plus sine iota sine theta 1 plus theta 2, right? That is it. So r1 is 10, r2 is, what is r2?
R2 is 2.
Very good. And cos theta 1 is,
Theta 1 is 2 pi by 7.
very good. And then theta 2 is
4 pi by 14.
9.
9 pi by 14.
Yes, it's 9 pi by 14 plus iota sine. Again, theta 1 is 2 pi by 7,
Yeah.
9 pi by 14. So you will get 20. 2 pi by 7 plus 9 pi by 14 is cos 13 pi by 14 plus iota sine.
13 by 14 pi.
Yes, okay. So this is how you multiply two complex numbers. And what do you see? That when you are multiplying two complex numbers, you are getting a complex number again, right?
Yes.
This is also a complex number because we have iota in it. Okay, this one, sorry. Okay, so this was the multiplication of two complex numbers. So we can also divide two complex, and division of complex numbers is very important. I told you already when we were talking about the simple form. I told you, do you remember that we multiply the conjugate and all that thing? Or you have forgotten that?
No, I
Um,
remember.
okay, right? So here we are
Yes.
dividing, but we are dividing two complex numbers in the polar form. So let's say, I will not do the proof again, okay? So I'll just write down the formula. So it is, if Z1 is R1 cos theta 1 plus iota sine theta 1. And if Z2 is R2 cos theta 2 plus iota sine theta 2, then you are interested in finding out the value of Z1 by Z2. Okay, so I will not do all the calculations and all that, but yes, you will be following a similar pattern, right? That you will multiply with the conjugate of this complex number because it is coming in the denominator. So finally, your answer is going to be R1 by R2 cos theta 1 minus theta 2 plus iota sine theta 1 minus theta 2. Okay. Now you need to understand one thing, that this R1 by R2 is just being multiplied with cos. Wait. There's some problem. Wait, let me just write it again. So it is R1, yes, it would be R1 by R2 cos theta 1 minus theta 2 plus iota. Okay, exactly. Okay. And if I refer to our previous conclusion, where we discussed the multiplication of two complex numbers, we got R1, R2, and it was multiplied by cos theta 1 plus theta 2 plus iota sine theta 1 plus theta
Minus
2.
theta 2.
No, it was plus theta 2, okay? In multiplication, okay?
Yeah, sorry. Yeah, it was plus.
Okay. So basically, I just wanted to write these down together just so we can compare. So you need to understand when we are dividing, you will divide R1 by R2. When we are multiplying, we will multiply R1 by R2. Everything is same except these signs. We have minus in divide. Yes, that makes sense. It's division. So we would have minus. And in multiplication, we will have plus.
You
Okay.
added. Okay.
Yes. So this is basically a way to which you can learn. But yeah, the rest of the thing is same. R1 by R2 is being multiplied with this factor and with this factor both. So these brackets are basically big brackets. Okay, I should make square brackets just so you are able to understand this. And that is it. Once you have your formulas, you can easily find out the values. So let's do another example. This time, again, the question is same, but you need to find Z1 by Z2. Z1 is 10 cos 2 pi by 7 plus iota sine 2 pi by 7 Z2 is 2 cos 9 pi by 14 plus iota sine 9 pi by 14. Okay. And you need to divide this time. So you have to find Z1 by Z2. So if we follow the formula, we have R1 by R2. Then what do we have? We have a big bracket. I should make square brackets. And then we have cos theta 1 minus theta 2 plus iota sine theta 1 minus theta 2. Okay, so I want you to tell me what is R1 by R2.
1 by R2 is 10 by 2, which is 5.
Very good. And what is theta 1?
Theta 1 is 2 pi by 7 minus 9 pi by 4, 14.
Hmm. Very good.
Plus, yeah. So 2 pi by 7 minus 9 pi by 14 will be negative 5 by 14 pi.
Okay. And again the same thing, right? All right. Okay. So you can just rewrite it as 5. Do you know that cos minus theta is basically cos theta because cos is symmetric, and sine minus theta is minus sine theta? Did you know this before?
Yes.
Okay, so we can finally write the answer as cos 5 by 14 pi plus, not plus, we can take this negative sign out and that would be minus iota sine 5 by 14 pi. So this would be the answer finally, right? So did you understand this
Yes.
completely?
Yes.
All right, okay. So that is it for today. We are done with the two sections. Like we are basically now on 9.5 geometric effects. We'll talk about that in the next class. So I'll stop sharing the screen, I'll stop the recording, and then we can discuss.